again to a class, a chemistry class, where we're treating periodic table. This is another class where we examine the periodic table the more. If you have not watched our previous classes on periodic table, you need to watch them. Very interesting, and particularly so as to be able to catch up. In our last class, we really spoke about some important aspect of the periodic table. We talked about transition of electron, how electron can move from lower energy level to higher energy level. We spoke about what is called valence electron, that is the electron in the outermost shell of an atom. We spoke about the calculation of neutron number, proton number, electron number, and the mass number. But today is going to be a quick class as well. We want to look at properties of elements, in the periodic table. Properties of elements. Now, the way elements are arranged in the periodic table, they are arranged based on some important properties. Now, that particular way by which those elements are arranged, as you can see, from lithium down this group, this is the same group, group 1 now, and from beryllium down in that group, there is a recurrence of character, recurrence of behavior between those elements. So we're going to talk about the physical properties first of elements, physical properties of elements in the periodic table. And as we talk about physical properties, under physical properties of those elements, we have atomic radius. We have atomic mass. We have density, so we have melting and boiling point, points. Now let's look at these one by one. Let's look at atomic radius. What is atomic radius? Now, the idea of atomic radius is the same as the idea of normal radius in mathematics. You understand, radius of a circle in mathematics is the distance between the center of the circle and any point on the circumference. And it is the same as atomic radius. So atomic radius is defined as the distance between the central nucleus. Now let's draw it down here. We know our atom have a central nucleus. And round about the nucleus, we have electrons. We have double electrons, the duplet in the innermost shell. Then we have one. Let us have one in the outermost shell. Now, the distance between the nucleus and the outermost isolated electron is called atomic radius. That is, distance between the nucleus and outermost isolated electron. That's what we call atomic radius, almost the same as normal radius in mathematics. And so, what is the behavior of this atomic radius in a periodic table? Now, atomic radius increases. It increases down the group. So, and decreases across the period. It increases down the group. Now come and see. This is lithium. From lithium to sodium to potassium to rubidium to cesium to francium, atomic radius increases. Then across the period, this is the period, the horizontal row is the period. It decreases the atomic radius decreases across the period. And if you want to examine that, look at it. This is hydrogen, helium, and lithium. 3 electrons. This is lithium. Now, if you draw, if you complete this shell, that is 3, 4, 5, 6, 7, 8, and you draw the next one, you will see that if I put 1 electron outside here, then the atomic radius will increase now to the outermost electron from here to here. So at every succession in the group, the atomic radius increases. Now let us talk about atomic mass now. Atomic mass. That is, if you follow our last class where we did calculation of atomic mass, proton number, electron number, you will recollect that we said atomic mass is the sum of protein and neutron in a single atom. So remember we said here that mass number, that's the same as atomic mass now, equals to proton number plus neutron number. And in the periodic table, atomic mass increases. It increases across periods, and decreases. It decreases down the group. It increases across period, that is the atomic mass. Now let's talk about density now. Density, as we often define, is mass per unit volume. Of an atom. That is, density is one of the physical properties of elements in the periodic table. Density of any atom is the mass per unit volume of that particular atom. How does it affect the periodic table? Just as we said, the mass number increases across period as you go across. The language is that across period and down the group. So density now, it varies across group and period, but generally it increases down the group and decreases across period. Increases down the group and decreases across the period. And lastly, we talk about melting and boiling point. What about melting and boiling point? Remember, we say melting point is the temperature. Melting point, now let's talk about this. Melting point, we say is the temperature at which a solid substance, turns to liquid. That exact temperature at which solid begins to turn to liquid is called melting point. And boiling point is the temperature, that's boiling point now. Boiling point is the temperature at which liquid now, boiling, at which liquid turns to gas. So simple, as simple as that. And how does it affect elements in the periodic table? Now, this also increases down the group. It increases down the group, So when it increases down the group, it means that it decreases across the period. So let's look at the chemical properties of elements in the periodic table. Now we have 4 properties here as well. We have what is called electronegativity. Electronegativity. That is the tendency of an atom to accept electron to itself, that is during chemical bonding. Now, as you can see from the table, we said we start from metals across the period, from metal down to non-metals. Remember, metals are positively charged. Then non-metals are negatively charged. No charge for element in this particular group. So electronegativity increases across period. So it increases across periods, and decreases down the groups. Now, because we move from positive and to negative, so it increases, electronegativity increases across period. Now, let's talk about number 2. This is 1, 2. It is called ionization energy. This is the energy required to remove electron from an atom. So it is measured in kilojoule per mole or kilojoule per mole this way. So let's leave it like this. So ionization energy. To understand this, let's use the idea of a shell again. Remember we said there is proton in the nucleus, an electron round about the nucleus. We said the electron is negatively charged, and the proton is positively charged. So, and remember that like charge repel. Only on like charges attract. So there are positive charges inside the nucleus, and negative here. So there is going to be attraction. And the farther the electron is from the nucleus, the lesser the attraction. You see, the attraction between this and the first electron here, that force of attraction is stronger than the force of attraction between this second one, which is in the second shell. So the ionization energy now will decrease down the group. You see, this is another one in this particular group. So as we go down the group, the ionization energy decreases. So it decreases down the group. So when it decreases down the group, then it increases across period and increases down the group and increase across period. So we look at number 3. That is called electron affinity. Electron affinity, it is like the opposite of the other one we looked about, ionization energy. So this is the energy released when an atom gains electron to itself. Remember, ionization energy has to do with release of electrons. So this one has to do with gaining of electron to itself. Yes, forming. When you gain electron, then you become negatively charged. So you're forming anions. And generally, this decreases down the group. Decreases down the group and increases across period. And the last one, number 4, that we'll talk about is called reactivity. Reactivity. How each element react, and according to how elements are arranged in the periodic table. So this is just the tendency of a substance. To form chemical or to react. To undergo chemical reaction. Let's use it that way. Undergo chemical reaction alone or with other substances. So this increases down the group. Viewers, let us quickly go through questions on periodic table. The following are selected questions for periodic table practice, and this is useful for candidates who are preparing for UTME or the WASEC exam, whether WAEC or NECO. Now let's look at this. This is a format of the periodic table. There are some letters here in the periodic table, and there are some questions that are being asked. For instance, which letter or letters could represent? Number 1, hydrogen. Which letter here could represent hydrogen? That should be this. If you have been following our class, hydrogen is letter A. Then number 2, 2 elements in the same group as each other. Group is vertical. Which 2 elements do we have in the same group? D and H. D and H. There are no 2 elements in any other groups except this D and H. Let's come to question 3. 2 elements in the same period. Let's look at period. Period is horizontal. Now this is second period. D and C are in the same period. Now if you come down, can you see F and G? And let's say with F and G. So of the same periods. Now let's continue. Elements that are metals. Remember, elements in group 1 are metals, group 2 are metals. These middle are transition metals. So elements that are metals are D, H, E, and I. Those that are metals. Elements that are non-metals, you can see non-metals here, C, F, G, and B. C, F, G, and B. Those ones are non-metals. An element with 2 electrons in the outside shell. 2 electrons in the outside shell. That is group 2. The number of electrons that you have in your outside shell determines the group that you have. Let's try it here. Group. First group. If I have 2 electrons, that's duplex. Then in the next group, if I have 2 elements, this will be element 1. Hydrogen, helium, lithium, beryllium. So beryllium is in group 2. If you complete this 8, we told us that The second shell will take 8 electrons, and you put 2 electrons in the third shell. Then you are going to have magnesium. This will be magnesium, which also is in group 2 of the periodic table. So if I complete this A and I put another 2 here, we will be meeting ourselves in group 2 until you get to the third period. Until you get to the third period where you start adding the 10 of transition element. But all we are trying to explain at this point is that an element with 2 electrons in the outermost shell is in group 2, and that is E. E is only E that we have in group 2. Then an element with 6 electrons in the outermost shell, that is group 6. So 1, 2, 3, 4, 5, 6. That is F now. F. Now let's continue. The most reactive metal. Now, the group 1 metals are the alkali metals now, are the most reactive. But remember when we're talking about reactivity under the chemical reactions of properties of metal of elements in the periodic table, we said that it increases down the group. So the most reactive now will be what? H, because down the group you found H there. Then a gas that is unreactive. Elements in group A are the unreactive element because their outermost electrons, their valence electrons are completed. It's either they are duplet 2 or they are octet 8. So these elements here in the last group, they are unreactive. So we have B there. Then an element in group 4. So group 4, 1, 2, 3, and 4. That is C. That is C. Let's solve more problems, and we allow you to also try some of these as we go down together, as we solve this together. An electron with an atom that loses 2 electrons. Metals lose electrons. That's why they are positively charged. Don't forget. Now, if the metal is losing 2 electrons, that metal is in group 2. An element with an atom that loses 2 electrons, and that is E. E. To get a complete outer shell, that is E. So, an alkali metal. Alkali metals are metals of group 1. Remember, we said group 1 elements are called alkali metals. So, for group 1, we have D and H in our table. Then a halogen, group 7 elements are called halogen, and in our group 7 of this table, that is G. So a noble gas, we said that group 8 element or 0 now, the last group, are called rare gases or noble gases. So the group 8 of our periodic table, the dominant one given is B. There is B, as you can see. Now, an element with an atom that has a complete outer shell, it is those elements too in the last group that have a complete outer shell, and they do not react at all. Their outermost shell is either complete, duplet, or octet. So it is the same B with an atom that has a complete, that is B. An element in period 2, remember periods, that element have 2 shells. Element in period 2, that is C. An element in period 2 is C. Then a transition metal, that is in between group 2 and group 3, you remember. So, and you can only see the only letter in between is I. So I. All those elements in that middle that we have not filled, they are called transition metals or transition elements. So what is the heaviest alkali metal? Now this is taking you to the standard periodic table now. The heaviest alkali metal is radon. And Number 18. What is the heaviest noble gas? The heaviest alkali metal, is heaviest. What is the heaviest alkali earth metal? That is radium. Radium. What is the heaviest noble gas? That is radium. Remember, this heavy that we are talking about has to do with density. And when we are talking about physical properties of the element in the periodic table, we're made to understand that the density increases down the group. So radon is heavy because it is located somewhere down the group 8. Then when an atom becomes an anion, what happens to its radius? The radius becomes larger. It becomes larger. And the last question here. An element with 11 proteins in the nucleus of its atom. Now we are talking about standard periodic table now. So elements that have 11 proteins. Remember, proton number equals to atomic number. So element number 11 in our periodic table is sodium. Sodium, Na. So you can see that periodic table is interesting. It is very, very interesting. You only need more time to familiarize yourself with this particular setup, how elements are arranged based on their properties. It's been so wonderful having you, viewers. Please do help us get this particular topic to those that are in need of it, particularly those that are preparing for UTME and WASE exams. Thank you for watching.